Hello everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So in today's video we will see the concept of absolute value function or modulus function. So I will be covering in depth about what is a modulus function and the graph of a modulus function, how it is different from other functions, and also I will show you a few examples that frequently appear in your exams on this concept of modulus function. Please do remember that this concept is widely used and widely tested across all exams, any entrance exams for that matter. Hence, it is extremely important for you to understand the concept of modulus in depth and very clearly. So if you're new to my channel, hi, I'm Deepthi, welcome to my channel. This channel is all about mathematics. In this channel, I will cover the foundations of all the important concepts of mathematics in detail so that you can use these concepts while appearing for any exams or in your day-to-day problems. So please consider hitting the subscribe button down below and also the bell notification so that you will never miss an update whenever I upload a video. And also request you to share this channel to as many as you can and help me grow on this platform. So now without wasting any more time, let's jump right into the video. So what is an absolute value function or a modulus function? Here, you can also call a modulus function as an absolute value function. So what is this function? It means that whenever you say there is a function that is defined from R to R, and when you write this function as y is equal to mod x, then if x here belongs to R, that means x is real numbers. So in this case, we'll call the modulus function as real valued function. Okay, because we are passing all real numbers. So y is equal to mod x, and if we pass all real numbers into this function, then the definition of an absolute value function can be written as y or f of x is equal to mod x. Okay, and this, you know, for a fact is called modulus, right? So what happens when you put the values of x inside the modulus? So we can define the modulus function as f of x is equal to mod x, wherein here this will be x in case x is greater than 0 or equal to 0, that is, in short, x belongs to what? How do you write greater than or equal to 0 in an interval form? Write this as this, right? And it will be minus x if x is less than 0, that is, x belongs to minus infinity comma 0. This is the definition of modulus function. This means, in short, I'll very clearly give you what it means. Okay, suppose we say x is minus 2, okay, so what will happen when you pass minus 2 into modulus function? What you need to do first, you need to check, okay, fine, what is minus 2? It is a negative integer, right, or a negative real number. So where exactly does minus 2 fall in this definition? It will fall under this, right, because x is less than 0 in this case. So if x is less than 0, what you need to do is you need to substitute x in minus x. That means mod x is nothing but minus of minus 2. You are substituting x in place of minus x and you are getting the answer as 2. That is what is happening whenever you pass a value inside a function. It will determine whether a function is a positive number or a negative number. Or in this case, a function is a non-negative integer or a negative integer. If it is a negative integer, it will put the value of x here, okay, whatever is the value, and then put another negative symbol in front of it so that it can be converted into a positive integer. So if you put a positive value, for example, x is 5 here, what happens? You know for a fact that x is 5 belongs to this domain, and when x is greater or equal to 0, the function is just plain x. So in that case, what happens? If mod x will become just x, x will become just x, and this is nothing but 5. So in this case mod phi is 5. But in this case mod x will become minus x, and we are substituting minus 2 in place of x, so that will become a positive value. This is a modulus function. So by definition now, let's just put this in a plain form, as in a form that is easily understandable. Here what I'm saying is, I'm saying that this is the input. Suppose we are giving this function into a computer, you assume, okay, and this is the computer. We have already defined this as mod x. So this is a function that will perform as per this definition, and it depends on the input that you are giving to this function. So here, if you are giving the input as minus 2, minus 3, minus 1.5, minus 65001, and also if you say you are giving 1 lakh, you are giving 10.5. These are the values that you are giving as an input to this function. What will happen here? It will perform its operation, right? This operation is nothing but this. It will check whether minus 2 is falling under this, or you will say 1 lakh is falling under this. It will check all the operations that it needs to know. So all these two will be in this function, right? Now after performing these operations, what is the output that you get of this function? What is the output now? Minus 2 belongs to x is less than 0 definition, and so you need to substitute minus of minus 2 here. You need to substitute minus 2 in place of x. It will become what? Plus 2. In the same way, if minus 3 substitute in place of x, it will become what? Plus 3. Minus 1.5, it will go, it will see, okay fine, it should be minus of minus. So it will become 1.5. The same way it will become 65001. But again, now it's a positive value. So 1 lakh, it will say, okay fine, I need to choose this definition for this. So it will become positive only. So 1 lakh. And then again you have 10.5 is also 10.5. Okay, so this is the pictorial representation of the function that happens here. In short, whatever is happening inside this dabba here, f of x is equal to mod x, is nothing but it will act according to the definition that we have given for modulus, and then it will give you the output. Okay, so you are saying that modulus is a real valued function. So it is a function, that means it will definitely have a domain and a range. So in this case, what do you think will be the domain and the range of a modulus function? Can you not say that you can pass any values, any real numbers into a modulus function? Right, we can do that, definitely. So domain of a modulus function will be all real numbers. Because real numbers, positive integers, negative integers, we can pass all these values inside the modulus function, right? Because we don't have any restrictions as well. It's pretty straightforward. So domain of a function is real number. Domain of a modulus function is real number. But what do you think is the range of the modulus function? You are passing all negative and positive integers or non-negative integers here, and this function will perform based on the definition that we have given here. But what is the output that you are getting after this function performs as per the definition? You are getting all positive integers, right? You are getting all the values as positive integers. You are not getting negative integers. So what will be the output here? In this case, the output will be positive real numbers. That's it. So the domain of modulus function is real numbers, and the range of modulus function is positive real numbers. So this is R and this is R plus. You can write this as x greater than or equal to 0, including 0. Well, if we pass 0 into modulus, we'll get 0 also, right? So the range will consist 0 as well. Okay, now how do you draw a graph of this modulus function? For example, let's say that this is the graph. Okay, now you know for a fact that x is the domain. If you haven't watched my previous videos on graphs of functions, I'll link it up here, you can watch. But here we can say that x is the domain, right? Now what are the domain here? Here I am passing all 5 negative integers and 5 non-negative integers into the function of f is equal to mod x. Okay, so now if x is 0, and you know that for definition this should be x when x is greater or equal to 0, and it should be minus x when x is less than 0. So when x is 0, this falls under this, the value will be 0 only, right? And when x is 1, positive, value will be 1, y. Here y is equal to f of x, you can say like this. Then if x is 2, then value will be 2 here. X is 3, value will be 3 here. X is 4, value will be 4 here. Okay, so this can be drawn as what? This. Assume this is a straight line, just drawing freehand. Okay, this is a straight line, just assume that this is a straight line. Okay, now what happens when we take x as minus 1? The curve or this line will shift towards left side. So that means minus 1, if you say minus 1, this falls under this, right? So minus of minus 1. So what is the output? Plus 1. Minus 2, output plus 2. Minus 3, output plus 3. Minus 4, output plus 4. Minus 5, output plus 5. So if you say this, so how do you draw this now? Like this. So what do you observe here? Here, for all positive values in the domain, you are getting positive y. For all negative values in the domain, you are getting positive y. So, the graph at x is equal to 0 is shifting from right to left here, right? So, this is the graph of modulus function. It's extremely easy if you plot some values and put in the definition and then plot the graph. This is how you represent the graph of a modulus function. So I would like to take an opportunity to cover one of the important application of a modulus function. So you know for a fact that any real numbers can be represented on a real number line, right? So a real number line looks like something like this. Say for example, this is 0, 1, 2, 3 and minus 1, minus 2, minus 3 and so on. So all the real numbers can be represented on a real number line, right? So modulus function can be used to measure or calculate the distance between two real numbers. That is, if you say I want to know the distance between x and 0, what you write is, you write this, right? The difference between x and 0 will give me the distance of x from 0, and you will put the modulus sign here because we know for a fact if you want to calculate the distance, it's always positive. That is the reason why we use mod in order to convert the negative number to positive. That means if we want to find the distance between x and y, for example, distance between x and y can be calculated using mod x minus y. So y mod, for example, if you take x is minus 3 and y is minus 10. Okay, so you are saying mod x minus y, substitute this minus 3 minus of minus 10. Right, here mod is for x minus y. It is not for individual mod x and mod y. Okay, so if mod x for x minus y, first we need to find x minus y and then we need to apply mod function based on the definition. So here we are getting x is minus 3, y is minus 10, minus of minus 10. So what do we get? Minus of plus 10. So we are getting this as the value, this as the distance. Here x is 7, here x minus y is 7. So if you apply mod on a positive value, you will get positive only. But in case if you reverse the scenario, if you say that x is minus y and y is minus 2, what will happen? It will become minus 5 minus of minus 2. So in this case, minus 5 plus 3 mod. So in this case, you get mod of minus 2. And if x is less than 0, you know for a fact this will become what? Minus of minus 2. So answer is 2. So in this case, what happens is the distance between two numbers on a number line or real number line or for anywhere for that matter, it can be positive or negative because we have negative integers also, or negative real numbers also is a part of the domain. So in that case, if you use the modulus function, you can eliminate that negative value because distance cannot be negative and it can be a positive value. Okay, so that's how you use modulus function. This is a very and important and most useful application of a modulus function. Now, how will the graph look like when we are calculating the distance? As in, how will the graph of, for example, mod x minus 3 look like? So now, let's look at the graph of x minus 3, mod x minus 3. Okay, x can take any values now here. You will notice the difference between the original graph of mod x and x minus 3 now. So if you say x is 0, you will get the answer is what? 0 minus 3 mod. So you'll get mod of minus 3, and you know for a fact this is 3. So this is 3. For x is 1, you get 2. For x is 2, you get 1. 3, right? And then what? For x is 4, you get again 1. For x is 5, you get 2. And so on. So that means this is the graph. Again, for x is minus 1, you get what? 4. So what are you seeing here? You know for a fact that mod x graph, the turning point of the mod x graph is at 0, but here the turning point of the mod x minus 3 graph is at 3. That means this graph has shifted right by 3 units. So now, if you want to calculate the distance from 0 to 3, we'll get 3 units. If you calculate the distance from 1 to 3, you get 2 units. If you want to calculate the distance from 2 to 3, 2 minus 3, you get 1 unit. If you calculate the distance from 3 to 3, there is no distance, 0 units, and so on. This is how you represent the graph of mod x minus 3. Using this technique, you can draw the graphs of various functions such as mod 2x minus 3y, very complicated functions also, x cube minus 4, anything for that matter, you can draw the graph based on this basis. Okay, so now let's see a few properties of modulus function. First property is, you know for a fact that x is a real number, and the first property is root of x square is mod x, right? We all know this property. So in this case, second is mod of mod x is mod x, right? That means here we get mod, here we get a positive value or a negative value. Out of this function we get a positive value. So if you put mod on top of a mod, then you get mod x only, right? Then if you consider a and b as positive real numbers, and x is also a real number, then you get the following properties. First one, if you say x square is less than or equal to a square, in this case, so if you say x square is less than or equal to a square, then you know for a fact that x square, if you are removing the square on both sides, you will get mod x, because we will write it as mod x is less than or equal to a, right? And then in order to apply mod on a, what we'll do is, you know for a fact that mod has two inputs, that is negative and positive, because it's a real number, right? So what we'll do is, we'll show this in the form of minus a whenever mod is negative, the x is negative, less than or equal to x, less than or equal to a. This is how you write x square is less than or equal to a square. Okay, now in the same way, what is x square is greater or equal to a square? Here you write this as mod x is greater or equal to a, and this will be written as, these are all the inequality properties that you remember. If not, please leave a comment down below, so that if you want to know more about inequalities, I'm happy to do a full video to help you understand inequalities. But if you say that x square is greater or equal to a square, and by removing square, you get mod x is greater or equal to a. So how do we know what exactly is the value of x? Where exactly does it lie? You can say, so you can say that x is less than or equal to minus a, or x is greater or equal to a. When you say x square is greater or equal to a square, this is one of the property. In the same way, if you remove the equality symbol on both these, then you get then a, you get minus a less than x less than a. These are widely used and tested in inequalities. So just tell me if you want me to do an in-depth video about inequalities. I will do it here because there in that video, because it's difficult for me to cover here. So here we get or x is greater than a. Okay. If you say that, you need to find this. How do you write this after removing the square? You say a mod x is equal to b. Same like this, but we have included another real number here. So we can say that x belongs to minus b comma minus a union a comma b. Okay, and along with these, there are some very important properties. So if you say that there is two real numbers x and y, then mod x mod y will be mod x5. This can be proved. Plug in any values of x and y, you will know for a fact that this is equal. Okay, or you can also write this as mod x5 is equal to mod x mod y. Okay, the next one is same. Here we are doing multiplication, now we are doing division. And in this case, definitely y should not be equal to 0 because it will be undefined. But mod x plus y is less than or equal to mod x plus mod y. And the same way, minus mod x minus y is greater than or equal to mod x minus mod y. This is for xy greater than 0. This is for xy mod x is greater than or equal to mod. These are the few properties of modulus functions. Here, these are very important. These are frequently tested. And we need to restrict the values of x and y. Based on the values of x and y, we can define these two properties especially. But yeah, this is what you need to understand. And these are all basically nothing but the definition of modulus. Depending upon that only we have defined these properties, and as I told you, it's not important for you to remember all these, but if you could just plug in the values of x and y to understand these properties, then it will be helpful for you whenever you try to solve any problems. Okay, so now let's see a few examples. I would like to quickly share with you a few examples where on how the absolute value function or modulus function will be tested in your exams. Especially when it comes to IIT and difficult exams, they will ask you to draw a graph of y is equal to mod x. They'll give you options and you need to select from that option. Okay, so in this case I have taken this example of y is equal to mod sin x. You know for a fact that sin is not an even function. We will get negative values, right? And how will the graph of sin x, normal sin x, look like? If you say y is equal to sin x, the graph is something like this, right? Graph is something like this. If you said 0, this is pi by 2 and this is pi. This is the normal sin x graph. Here they are asking you to draw this. You need to know. Okay, you need to know the sin x graph in order to draw the graph of y is equal to mod sin x. If you want me to do a dedicated video on trigonometry, please leave a comment down below so that I'll start that series as well. But for now, this is the graph of y is equal to sin x. So how do you draw the graph of y is equal to mod sin x? You know that sin is not an even function. You know that there are values in negative. So by applying mod, what will happen? The negative values will be removed, right? So in this case, let's take for example, here y is equal to mod sin x, and this definition itself is that y will definitely be greater than 0 because we have mod. Now if you put various values of x, for example, if you say what will happen when x is minus pi by 2, we'll get what? Minus of sin pi by 2, right? When x is minus pi by 2. So what we'll get? Minus of sin pi by 2 is 1. So we get this as what? Minus of mod 1, which is nothing but 1. Right. So that means, can you not say that this minus pi by 2, x is minus pi by 2, will become a positive value here. So rather than the graph being minus 1 here, it will go here. So can you not say that this will be like this? Right. Now, again, if you say minus pi also, you'll get 0. 0 is always 0, right? Minus 3 pi by 2 also will get positive value, and then you'll get like this. And this also will not result in negative. Here sine 3 pi by 2 is minus 1, but when you apply mod, you'll get this as positive value. So you'll go again like this. So in short, what can you conclude? Mod sin x is on the positive y-axis side. That is, you can replicate this graph as somewhat like this. Right? So that is how you draw the graph of y is equal to mod sin x. It's very easy if you input a few values in order to understand or draw the graphs of any functions for that matter. Okay, so this is how they will test you, one of the ways in which they will test you on modulus, and the other way would be on inequalities. Modulus is frequently and mostly tested on inequalities only. So they want you to solve for x if mod of minus 3x plus 4 is less than 2. That means here minus 3x plus 4 is less than 2. This is in the form of what? Mod x less than 2, for example. How do you write this? You write this as 2 minus 2 less than x less than 2 for the definition of modulus, or for the property that I have shown you of modulus function. So in this case, rather than x, we have this function. So how do you write this now? Minus 2 less than minus 3x plus 4 less than 2, right? So now you need to get x here. So what you'll do is you subtract 4 in order to simplify this in the next step. Subtract 4. What do you get now? Minus 6 less than minus 3x less than minus 2. Now then you need to get the value of x, not minus 3x. So just divide this. What do you get? 2 less than x less than 2 by 3. You know for a fact that these are negatives. So in order to cancel the negatives, what we do is we will change the signs. So it will be like this. Okay, x lies between 0.666 and 2. X lies between these numbers. Okay. This is how you solve one of the problems related to inequalities that involve modulus. This is a video in depth about modulus function. I hope I have made things very clear for you regards to modulus or absolute value function. So if you have any questions, or if you would like me to do any other topics, please leave a comment down below so that I'll be able to start a series on those as well. So if you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. I will see you all in my next video. Until then, I hope you have a safe day and a wonderful week ahead.